Hey colleague, you are welcome to Group 2 presentation of the Zoo Management System. The Zoo Management System project aims to revolutionize the way zoo operate by implementing a comprehensive technology solution. The system encompasses various aspects of efficiently managing animal record and health to enhancing visitors' experience and optimizing operational workflow. Among participants in the group are Parjad, who focused on software development, creating intuitive interface and functionality; Kateryna, who specialized in database design and management. She also helped in software development; Chris, who oversees project management aspects, handling project timeline, resource allocation, assisting in software development, and coordinating team members; Ademola, my humble self, who worked on pseudocode, project write-up, and also software development. Primary objective of this project was to create a sophisticated terminal application capable of efficiently overseeing and handling the diverse operations within a zoo facility. This encompasses the design, development, testing, and deployment phase, necessitating an essential component for its functional success. To ensure a robust and manageable code base, the project extensively utilized object-oriented design principles like inheritance, polymorphism, and encapsulation. Thorough testing procedures were executed to guarantee error-free compilation and runtime functionality devoid of memory leak.
Hi, my name is Parjad. I'm going to introduce the program. This is the screen you'll see after you successfully log in into the program. Welcome, John Doe. That's the zookeeper's name. I'll start from the top, from number one. Inventory management is where all the animals are stored, where you can add, remove, and edit animals' information. Number two is reporting. That's where you can find information about a specific animal based on their ID. This is ID-based program, so you have to know which ID your animal you're calling. Or you can show all the animals' information and just search through them and find the ID for future references or information, any other information you like about the animals. Extra is where eat and make sound takes place, the virtual functions. When you feed the animal regular food, you give them 10 points. When you give them special food, you give them 25 points. This happens by demonstrating overriding these virtual functions. And make sound makes regular sound and extraordinary sound. Animal attribute number four is where encapsulation takes place, where animal attributes such as age, weight, and name are modified by implementing getters and setter methods to enforce data encapsulation. And number 10 is clear screen. That's if it gets too cluttered. And number zero is end the program. That's where the program terminates and ends successfully in a safe manner. And insert data value is where exception handling takes place to make sure that you enter the right information. Thank you very much. Next slide. Hi, this is the next slide. I'm going to talk about the login menu and the main menu. For demonstration purposes, the username and the password for the login menu is 11111, as you can see from the screen. The user has three chances to attempt this to put the right password and the username. If they don't, they will be locked out and the program has to be rerun. If they do, you will log into the main menu as I described the main menu. There's exception handling, obviously, to make sure that the user enters the right value. For example, if you put special characters or string values, the program does not crash. And next slide. Hi, I'm going to continue talking about the program. I'm going to talk about inventory management and exception handling. As you can see, there's seven choices in the inventory management. This is where you'll see what you'll see after you press one from the main menu. Add, remove, feed water animal, hydrate, and clear screen. Return to the main menu. Clear screen is the same as the main menu. It just clears the screen once you press that option. It will clear and make it clean. Zero goes to the main menu. Only from the main menu can you exit the program. Other than that, zero will just go through the ranks and it will go back to the main menu or the main option. Um, Add animal, as you can see, I will talk about soon. Remove animal based on ID. Feed animal, will feed the animal and give it 10 points. Water the animal, will water the animal based on ID as well. They're all ID based, and it will give it different 10 points. And hydrate animal will also give it another 10 points to the hydration level. And you have to choose the animal based on ID. This is ID based. So you don't guess it based on the where it's located on the vector, but just ID based. So the user only selects by ID, not by name. So they can have the same name, but they will all have unique IDs. So ID is the primary key, and you can use that to gather and store information and edit and remove information. So I'm going to talk about the add animal. One, as I press, will ask for the name. And here it's the elephant, and then we'll give the animal its unique ID. So even though elephant is already on the menu, there can be another elephant, but they are different IDs and different attributes. So it will then ask for age, weight, health score, nutrition, hydration level. If entered successfully, it will give the message you have successfully added an animal. If you press the invalid information, as you can see, exception handling, if you write in string, it will ask for it again. It will keep on asking until you enter the right value, which is a integer value. It will not crash. This is a very good program, and it will not crash. It will just keep on asking until you successfully add it. And in the demonstration, it shows it, but on the right side, it shows that what will happen if you enter the wrong weight or put a string in it. Thank you, and my colleague will continue on the next slide.
The inventory report function is called when the user selects the option to generate an inventory report. This function takes a vector of zoo object as a parameter and generates a comprehensive report on the zoo's animal inventory. It prints a formatted table with information such as ID, name, age, weight, health, nutrition, and hydration for each animal. The option 3 function is responsible for making animal sounds. If the user selects the option to make a sound, they are prompted to enter the ID of the animal and choose whether they want the animal to make a small or big sound. The code dynamically creates objects of different classes derived from the animal base class, such as cuckoo base, hyena base, wolf base, and others. The specific animal sound making function is then called based on the user's input. Additionally, if the user selects option 2, a special case of the Siberian blue robin is handled. In this case, a vector of pointers to the animal base objects is created, including instances of bird, robin, and Siberian blue robin. The user can choose to make sounds for these special animals, and the corresponding display function is called. The option 4 function serves as a menu-driven interface for updating specific properties of animals in our zoo. The user is prompted to choose from options like setting or getting the animal's name, weight, or age. The function incorporates exception handling to ensure that the user provides valid input and handles errors. After the user has provided the ID of the animal they want to modify, the system prompts the user to update the chosen property. The function has a copy-paste mechanism and uses two vectors. The user makes changes in a temporary vector, and if the changes are successful, the updated information is copied back to the original vector.
Hi, I'm Chris, and I'll be talking about the software design process and how it was used in this project. The software design process has several time-tested elements that have shown to improve problem solving, facilitate communication, and reduce coding time. This project employed pseudocode, flowcharts, and UML diagrams. Let's start by discussing pseudocode. Pseudocode is an informal way to develop major program logic and program flow with natural language. In this project, pseudocode helped to improve understanding and communication during the design phase by removing the burden of technical jargon and the formality of programming syntax. This group exercise yielded excellent results and exchange of ideas. Here you can see that global variables would be needed. Major application functionality would need to take place in a zoo class, which would then act as the management module of the zoo's operations. The animal class is the base class that contains all the generic properties and methods that every animal object will require. It is reasonable to assume that every animal will have a name, an ID, and a weight. The generic quality of these properties makes it possible for a more specific class to inherit its properties and add more specific characteristics on top. For example, a bird may inherit all the qualities of a generic animal, but add wings. Inheritance is a key concept of object-oriented programming, which tries to mimic the hierarchy and organization of the real-world objects. Here in the pseudocode, we begin to develop the ideas, the data members, and member functions that will be required for the application to function. Flowcharts build on the design foundation established by pseudocode. This technique can serve to visually depict the program flow and logic decisions for the non-technical business person and the visual thinkers in the design group. It is powerful when fully utilized and will reduce coding time by fully developing the decision-making process, separating it into isolated functions, and show the direction of the program flow, including loops, switches, and yes/no decisions.
Unified Modeling Language is a tool used in the field of software engineering to create visual representation of a software system, such as its structure, behavior, and interactions. Our UML diagram for the zoo management system depicts a representation of the system's structure and class relationships. At its core, the system is composed of three main entities: zoo, zookeeper, and animal. The relationship between zoo and animal is a composition relationship, as animals are part of the zoo. Each zoo owns a collection of animals. When the zoo is destroyed, the animals it contains are also destroyed. The relationship between zookeeper and zoo is an association, as a zookeeper works in a zoo but is not a part of the zoo itself. The relationship is more of an association rather than a composition. All the animal classes inherit from the animal base class. For example, the abstract class wolf base contains virtual functions, make sound, and eat, while the concrete class wolf derived inherits from the wolf base and provides specific implementation for the virtual functions.
The key elements of object-oriented implemented are encapsulation, inheritance, and polymorphism. We utilize the principle guiding inheritance, encapsulation, and polymorphism in our work, citing a classical example of the class lion from our code snippet. In the provided code snippet, encapsulation is utilized through the use of private member variables, which are name, ID, age, weight, outscore, hydration level, and nutrition level. Within the animal class, these variables are not directly accessible from outside the class, which helps maintain data integrity and security. Encapsulation allows controlled access to this variable through public member functions, which are the getters and the setters, provided within the class. This ensures that the internal state of the animal can be accessed and modified in a controlled manner, preventing direct access to its private variable from external code. For instance, the setters, which are set name, set age, set weight, allow setting the values of private member variable based on certain condition or validation rule defined within the function. However, getters, which are get name, get age, and get weight, provide read-only access to those private variables, allowing other parts of its program to retrieve the value without directly manipulating the private data member. Inheritance. The class Barbary Lion derived is derived from the base class base using the public keyword. This establishes an inheritance relationship implying that Barbary Lion derived inherit properties and behavior of the base class. Both classes share common function, make sound and hit, which are inherited by the Barbary Lion derived. The inheritance mechanism promotes code reuse and establish a hierarchy relationship between classes. Polymorphism. Both make sound and heat function are declared as virtual function in the base class. This indicates that the function can be overridden by a derived class. In the Barbary Lion derived, these virtual functions are indeed overridden. This is an example of polymorphism where a single interface, make sound and heat, is implemented differently by the base and the derived class. Our code utilizes inheritance to establish a hierarchy relationship between classes, encapsulation to encapsulate function within classes, and polymorphism to enable different implementation of common function in derived classes.
Application development is done by teams. Today, team members can be anywhere in the world and use many different tools. Seamless communication and file exchange are critical factors for success. This project used Microsoft Teams for communication, Office 365 file sharing, and GitHub for source code control and versioning. GitHub is a web-based front end for the Git process. Git is a source code control and versioning system that makes it possible to roll back to previous versions of files, share code with remote contributors, and let them commit code into the repository. Rapid iteration is made possible by the use of branches. These branches become isolated testing grounds for new features and can be merged back into the source code upon completion. Originally a command line utility, Git now has many plugins for popular IDEs like Visual Studio to make working with the tools very easy.